Hi, in this video we're going to go over how to configure Python to call C++ code via the library pybind11. This is a powerful software architecture tool because it will allow you to perform high performance computing in Python, which as an interpreted language it is sometimes slower, so you'll be able to call highly performant C++ code, um, as you can see in the following example, where we have here a data structure that has hello world from only Python, and it passes it to this function which has a simple Python implementation where it simply iterates over this list of dictionaries and prints it, right? As we can see here when we call it python main.py, right? It simply prints hello world from only Python that we see here. But then this one is more interesting because it says hello world from Python C++ interrupt, and which is basically the same type of data structure as before. But when we look at the implementation, we actually see that we cannot control click into it because there's no Python implementation for it. Instead, this is actually implemented in C++ over here. We have this print vector of unordered map, which has a similar signature, basically a list of dictionaries. The closest thing in C++ would be a vector of unordered map, and it iterates the same way. It basically prints the same, but from C++. So what we're gonna do next is we're gonna start over from scratch, because this is what we'll have at the end, so that you can learn step by step how to achieve this. And then lastly, as a bonus, we're also going to go ahead and learn how to place breakpoints on the C++, because if you are trying to develop a complex feature, having the ability to do this, just call C++ and have breakpoints and be able to inspect your code in C++, even though it was called from Python. We'll go over how to do that at the end as well. All right, so let's go ahead and move over to the guide GitHub repo for this video that you can find in the video description below. So we'll go into the commits area where we have these described step by step. So this initial commit does nothing really. It starts getting interesting here in the step 1 commit, where what we do is we follow the instructions from the official VSCode documentation site, and here they explain to you how to build a simple hello world style project. I have followed these instructions, and I've added a few things here that you can see here, such as changing the standard to C++20 and a few other differences from the official documentation, such that when we check out into that commit over here, we reach the following state. Now that we have traveled back in time, there's no Python yet, so what we have here is just a very simple C++ only project at the moment. So if you're trying to implement pybind11, I would recommend start with the C++ side. That makes things simple for me. So here we're starting with the C++. I've configured it to create this build folder over here. So let's go ahead and run it. And yeah, so it prints this hello world from only C++, and it has the same implementation that we saw at the beginning of the video. So no Python at all yet. So we're ready to move over to step 2, where we will add the matching Python code. So what we will do in step 2, simply this: we will create basically the same that we have on the main.cpp over here. We will do its Python version, and we will add the Python implementation of the print function. And we will state our goal, which will be to create the C++ function that will call the C++ code. So let's go ahead and check out into that step. All right, so at this stage, no changes on the C++ side. We only added the Python, so we are able to, should be able to print it, yep, and it prints as expected. So now we are ready to move into step 3. So in step 3, we will try, it's an attempt to include pybind11, which will of course fail because we have not actually copied over any pybind files. So let's go ahead and check out into step 3. All right, so we go over to main.cpp, we find this over here, and as expected, we get the red wriggly lines, and if we try to build, it will fail because it's unable to find pybind11. So what we need to do here in step 4 is go ahead and download pybind11. In this project, as you can see here in the comment for step 1, I am not using CMake or any advanced build system. Simply using the bare bones that provides VSCode for small C++ projects. If you want something more complex, you can go here in the documentation and you can find information about how to include CMake and have a more complex C++ project, but we will not go over that in this video. All right, so we'll go into pybind11 and just simply click on download zip. We will download the whole project as a zip file. All right. And then we will find it in our we'll find it in the downloads area, and then we should be able to extract it. All right, so now what the files that we need, we will find on their include folder. So it's going to be here, include, and we'll find pybind11 here, and here's all those header files that we need. So let's go ahead. I've already done that here in the step 4, so let's go ahead and check out there. All right, so here in step 4, now we have the include folder with pybind11 only. And in addition to just copying that, I've also added the necessary configuration changes, which is only these little bits here in the C++ properties. This will give us, this will tell the editor, the VSCode editor, to remove those wriggly lines. And then we also need to add them to the compiler, to the MSVC compiler for Windows. Then you might be wondering about this compiler flag. This is a recommendation from the official pybind11 documentations for Windows. So they recommend here that it is advised to add that permissive flag, and I recommend everyone to do it. It's worked for me by adding the flag. If I remove it, it also works, but since they recommend it, I probably won't hurt to have it in there. All right, so after this step, let's try to build again. And it fails again because now it wants a python.h file. So this python.h file, this actually is a built-in header file that the interpreter that we are using contains. So we need, at this point, we need to figure out where our interpreter is located at. So to do that, I will open a command prompt and I will use where python. With this now here, I'll navigate into this location where my Python installation is located. And yep, all right, so here we see the include folder, and when we click into it, we do find that Python file that we were looking for, which is right over here, python.h. So let's go ahead and check out that next step right over here. And what we see is that we are including the location of our installation, right? Both in the CPP properties to remove the red wriggly lines and tasks.json so that it compiles. And let's go ahead and check into that commit. And let's try to build again. So notice that by doing that, we no longer see the wriggly lines because the files are included. However, when we try to build again, we see errors once again. And that's because we're missing this dynamic library over here. Fortunately, that library is also found over here, this Python 313.lib. So we also need to add a location for dynamic libraries to be found. And we see that in the next library over here on step 6. So we see here that we are adding the location with the libpath compiler flag prepended. We also add the link compiler flag to let it know that the following commands are for dynamic libraries. And last, it's important to set the machine type. It should be 64-bit for most of us, but this could also be 32-bit, in which case it would be x86. So let's check out into that commit. All right, and let's try to build once again. And at this stage, things do pass. So we are now ready to go ahead and set up the configuration to use C++ from the Python side on step 7. So now that everything's passing on step 7 first, we will tell the compiler that we're going to create a dynamic library because in Windows, the created Python modules to call C++ are themselves dynamic libraries, and we specify the name of the file will be print_cpp.pyd. And then in our main.cpp, we define this module that we will create. As a good practice, I like to name both files, both module and PYD file the same. And then we provide a simple doc string, and then we define each function that the module will export. In this case, to avoid any confusion, I will call, here's the function pointer that we pass, and I will call the Python associated function to call this function pointer the same. I like giving them the same names. And you can also provide a doc string for it. So let's go ahead and check out this step. Right, and here we see those changes, and we should be able to build this as well. All right, it did build properly, so now we're ready to import it and use it. So now moving over to step 8, we go ahead and first we add the build folder, which is where the PYD file is located. It's right here. We add that build folder to our Python path so that we can import from it. And then we import the PYD file like that. There's no need to do .pyd. So we import that PYD file. These PYD files do not include Python typing, so I do type ignore to not get red wiggly lines in my editor. And then we can implement that function and delete the stated goal docstring. So we do get that function that takes in the list of dictionaries and passes it over to the underlying C++. At this point, you might be wondering how is it that um, this binding happens automatically? How is it that we're able to pass a list of dictionaries into this function that takes in a vector? So fortunately, pybind11 does this for us. It does include some automatic conversion for standard library containers. So specifically, it will map vector into list and unordered map into dictionary. As you can see in the documentation, one drawback of this is that it does do copy operations each time the binding happens. So if you're passing very large lists or dictionaries, you might get a performance hit. You can inspect the documentation here for more advanced techniques on how to prevent the copy from happening, because there are indeed ways to use references for better performance, but we won't go over that in this video. All right, so now that we have imported the function, we're ready to use it on main.py. We create the new data structure to just say hello world from Python C++ interrupt, and then we call that new function. So let's head into that step. All right, and at this point, we should not need to build because we didn't do any C++ changes. So we should be good to go at this point. And yep, we do see the call on the Python only function and the Python C++ function as well. All right, and to finalize, let's go over the final step that we have here as a bonus of adding debugging capabilities. So if you have a complex project, it can be very helpful if you are able to place breakpoints both in your Python and C++ code. And we can do that by adding some debug configurations as here. So let's take a look in VSCode. Let's check out into that step. And if we go take a look at the launch configurations, we can see we've added 3. This first one, it's a Python debug configuration. So what it does is that it runs a Python program, in this case main.py, and it adds debugging capabilities to it. So let's go ahead and run that, and we'll see something interesting happens, and it's that we hit a programmatic breakpoint here after printing the process ID. So what's going on here is that we've initiated a Python process and we are observing it via the Python debugger that initiated the process itself. However, in VS Code, we're only able to observe one language per debug process. So we wouldn't be able to debug C++ with this one. But what VS Code does allow is to attach subsequent debug processes into existing processes that are running so that you can do multiple language debugging at the same time. So by adding the programmatic breakpoint, we stop time and we give ourselves the opportunity before the C++ runs to attach the C++ debugging such that when the C++ does run, the debugger is already observing the code and we can hit breakpoints. So let's go ahead and run this second one, C++ debug with Python attach. And notice that now it's asking what process to attach to, right? That's when this ID comes in handy because we're able to find the Python process that's gonna call the C++ later on. So in this case, 388. We find it, and yep, we simply attach to it, right? So now our C++ breakpoints will hit as well. So let's go ahead and put a couple of breakpoints. I'll put one before the first Python call and before the second one. And let's put this one right here before C++ called. And let's add one to the C++ itself. So let's go. We're currently over here. Let's hit the breakpoint. So the first one hits as expected, right? This is right before the function runs. Let's hit it again. Now the first Python only function has ran. And we're about to hit the second one that does the interrupt. So let's hit it. And this breakpoint hits right before. Now the next breakpoint that should hit is the C++ itself. Let's go ahead and hit play. And notice that I'm hitting play, but I am not seeing the breakpoint hit. This happens sometimes. Ideally, it would hit automatically, but you might need to switch, and then it had already hit, but it wasn't showing. Sometimes it does do it automatically, but sometimes you do have to switch around. But yeah, basically now we have breakpoints in both languages, and you can see we can inspect what's going on here in the C++. The first one is value hello. The second one is world, the next one is from, and then the last one is the interrupt, which is what we were seeing here in the data structure that we passed in. Now this works out all right, but on certain occasions you might want to skip the Python and go directly to C++ so that you can avoid this part of adding the process ID. To do that, we've added this last configuration where we only do C++ debugging, but we initiate the Python process. So we initiate the Python process, but we don't observe it. We only observe the C++. This can be helpful if you want to focus only on the C++ debugging. So we hit it, and the breakpoints do hit as expected, but notice that all of the Python breakpoints were skipped. Yeah, and that concludes the video. Good luck with all your Python C++ projects.